say it's fun. Not easy, but fun. Yeah, fun. Fun. Okay. Okay. Now, listen, this topic is called trigonometric substitution. It's basically like a combination of substitution and trigonometrics. The one that we saw on Monday, the one that we saw on Wednesday. Okay? So we're going to use that a lot. The idea of this technique is that if in an integral you have one of those three factors that is a square root with a binomial, the idea is to change that expression into something else in terms of theta, which is an angle. To do what? Well, to make the integral simpler. That's the idea. So, depending on the situation, you have this one, or that one, you need to apply a certain procedure to start and then solve. For example, that one, x squared over square root of 9 minus x squared, you cannot do it directly. There's no formula for that. You need to change it to a function in terms of theta so you can solve. Okay? Before I start, a question for you. Do you remember Pythagorean theorem?
Lo vimos en filosofía.
¿No? ¿De verdad? Lo vimos en filosofía. ¿Quién es el clase?
Un abogado. Yo sé.
No, está bien. Seguro que lo ven en filosofía. Tienen una conexión. Okay, number 2. Do you remember about the sine, cosine, tangent, etc.?
Yeah.
Okay, if you do, then you are half the way to solve this. If not, then too bad. Okay, we'll see. First one. Let's start with the first case. If the integral has this factor, the square root of a squared minus x squared, such as that one. In this case, what we're going to do? We're going to change this into a function of theta, but by using what? Triangles. A right triangle. We're going to build our own right triangle for this expression. Imagine this. I'm going to build a right triangle for this. And I'm going to find the values of the sides of that triangle. This is going to be my angle theta, this is going to be the right angle, and now from this we're going to get the measures of the sides. Okay? To understand that, you need to remember the Pythagorean theorem. The Pythagorean theorem says what?
A squared plus b squared equals c squared.
Let's use instead of AB, whatever, let's use the words. Hypotenuse to the square equal to side 1 to the square plus side 2 to the square, or cateto in Spanish. Okay? What happens if I isolate the hypotenuse? What do I get? Of the first side plus the second side. What happens if I isolate one of the sides? Which one? Whatever. Any one of those sides.
The square of the side equals hypotenuse minus
The square root of what? Hypotenuse to the square minus the other side of the square. Okay? So the idea is using this information to see what happens with these three cases. Because of that formula, of those three formulas, from here, which one is my hypotenuse? A. A. Okay? You understand why? Because of this. This one. One of the sides is a square root of hypotenuse to the square minus one of the sides to the square. This, the same as this. And in this case, the a squared, the hypotenuse to the square. The hypotenuse is a. What about the sides? Well, you could say that this is going to be x, or this could be x. in this case, what I want to do, the idea is to always to change later, we're going to represent the variable over 8. Okay? So, in this case, for example, if I say that x is this one, because it's the other side, what would be the function that I need that represents x over 8? Sine of theta. Sine of theta. Okay? Let me retrace my steps. Do you understand what is this x? Check the formula again. This is the hypotenuse to the square and the other side to the square. Which side? That's up to you. But in this case, I decide that is this side, the opposite side. Therefore, this side is going to be what? The whole square root. Get that? So, in this case, for example, since I put my x here, and if I divide it by the hypotenuse, so now I have x over 8 is going to be sine of theta. And if I isolate my x, to do what? To substitute later, x is going to be what? 8 sine of theta. And if I were to put the square root of a squared minus x squared over the constant, which in this case is 8, what function do I need? Cosine. Why? Because it's adjacent over hypotenuse. So, if I isolate the square root, is square root of a squared minus x squared equal to 8 cosine. Yeah? You may wonder, why do I need to put this like this and then isolate, or this like this and then isolate? Because the idea is to change what I have in my integral to something in terms of theta. So I need to have an expression that only has theta. That's why I leave it like this and then isolate, because now I need to change it. Also this one, I have this one, I change it, so now I have the square root in terms of theta only. Do you understand that? Some of you already know this because we already saw that in our form. Not all the great pictures, but it's not that complicated. Fine. Let's use this to solve that exam. Okay? I have this integral, which is x squared over square root of 9 minus x squared dx. I cannot solve it like that. What I'm going to do? That procedure. To do what? To change. So in this case, for example, with this is going to be my triangle. Let's see. My triangle here. My angle theta. Which one is the hypotenuse?
9.
No. 3. This is x, and this is that, square root of 9 minus x squared. Therefore, x over 3 equal to what? Sine of theta. Therefore, x is equal to 3 sine of theta. Square root of 9 minus x squared over 3 is equal to cosine of theta. Therefore, the square root alone is 3 cosine of theta. Do you get that? Same thing as I did there. And what's the reason of this? Because now I can change everything in terms of just theta. So it's going to be an easier integral, supposedly. Okay? Okay, so new integral. Instead of x squared, what happens? Will be 3 sine of theta to the square over, instead of the square root is
3 cosine of theta.
Cosine of theta. And in this case, if you observe, I change this into this, I change this into that. Am I missing something?
dx.
The dx. I cannot put dx here because I change to theta. So what do? How do I get d theta from this information? How do I get d theta? By differentiating what? Yeah, you're right, but what? Aha, this expression. X dx, 3 sine, 3 cosine of theta. In theta. Pues los separados in theta. So, 3 cosine of theta.
¿Por qué me está ahí otra vez el trigonometric?
Instead of the dx. Coincidence? Well, that's because of the function. Yeah.
No, pero acá el dx tiene que usar lo que tenga x es igual a...
That's why you need it isolated. Good. Questions so far?
No, está todo bien.
Now what? Let's simplify. Can I simplify? Yeah, I can simplify all of this with this one. So the simplified integral is going to be e to the square is 9 sine square of theta d theta. So 9 integral of sine square of theta d theta. Now what? Can I find the integral of sine square? Yes, but we did on Wednesday, remember? We need to change it using an identity. So 9 integral of sine square of theta, if you remember, is 1 minus cosine of 2 theta over 2 d theta. I reduce the power. And then, if you want to, you can separate. So it will be 9 times 1/2 is 9/2 integral of d theta minus 9/2 integral of cosine of 2 theta. What did I do? I just separate 9 times the 1/2, 9 times the cosine over 2. And put the coefficient outside. And then integrate.
¿Por qué de tu tira?
The thing. Remember the one that was almost. Check your notes. It's the one that about the relation of the power. 9/2 of d theta, 9/2 of theta, minus 9/2 times integral cosine of 2 theta is going to be what? Sine of 2 theta over 2 times 9/2, 9/4. Remember what?
It was like the inverse
Of the chain rule. Yeah. So cosine of 2 theta integral is sine of 2 theta times the 2 and 9/2, 9/4. Okay?
¿Lo entiendes?
Yeah, but I have with the little box, so it's not. Is that my answer?
No.
No. It's not.
Yo me había emocionado.
Yeah, igual. What happened in substitution at the end of the exercises? If the original variable is x, but now I have theta, what do I need to do?
No tenemos que
Go back.
el valor del d.
Go back to x. Yeah, go back to x. But before that, there's a problem with the sine of 2 theta. We need to change it using another identity. So, would be 9/2 of theta minus 9/4 2 sine of theta cosine of theta. What did I do? I applied a trigonometric identity to change this into all of this. Double angle formula. Why? Because in this case, for example, I need to put it in a single theta to use the triangle to go back to x. With 2 theta, there's no 2 theta in the triangle. I only have theta. So I need to change this into this. So now I can change it to x again. And now, 9 halves theta. How do I change theta to x? No. Isolate from where? Could be from the triangle, yeah. From the triangle. Okay, from the triangle, how do I get theta? Or even better, here you have x over 3 equal to sine of theta. So from here, what's the value of theta? Arc sine. The inverse function. Remember, Math 4, inverse function? 9 halves arc sine of x over 3 minus 9/4 times 2 is 9 halves. Sine of theta. Sine of theta is what? X over 3. Cosine of theta. Cosine of theta is the square root of 9 minus x squared over 3 plus 6. Can I simplify it? Yes, a little more. 9, 3 and 3 is also 9. No, yeah. Also need to simplify. Remember. Final solution. 9 halves are sine of x over 3 minus x square root of 9 minus x squared over 2 plus 6. That's the answer. Now I put the box.
Why did you put the square root of 9 minus 2x?
Instead of cosine, I put the value of cosine x. That's it. Yeah.
No entendí por qué x sobre 3 se volvió arc sine.
So I need to isolate theta. So I need to get the theta only, not the sine. The theta only. So how do I get theta? How do I get rid of the sine? With the inverse function. What's the inverse function of sine? Arc sine. Yeah? That's case number 1.
Pero fue otra vez porque el sine de ahí se convirtió en el verde. Ajá. El sine se convirtió en eso.
This is cosine. So
Solo ahí se simplificó el cuarto profesor, ¿verdad?
Yeah.
No, no.
yeah. That's a formula. Identity. From the ones that did we see that in math? 4. Yeah, we did. Mate 4 ustedes llevan unas identidades. Después de las primeritas básicas, también vieron una suma y diferencia. Seno de x más y. Y luego vimos unas de seno de 2x. Entonces vamos a dar. Vamos a dar esas identidades. Vamos a dar. Tenemos que usarlo. O sea, a ver, escuchen, va a dar formulario en el quiz del viernes que sigue, pero lo que vamos a dar en el formulario son las derivadas, las identidades y ya. Pues sí, derivadas y identidades nada más. Las integrales, pues no. ¿Ok? Fine.
O sea, no entendí que no como, o sea, la que tiene en negro, la flechita, porque no se
Es una identidad.
Ah, ¿sí es?
Sí, es una identidad.
Entonces, ¿qué pasa con el 2? Porque no se multiplicó por el 9.
Pues es que es 9 cuartos por 2, 9 medios. Y el seno de teta lo cambié a x sobre 3 y el coseno a la raíz sobre 3. Simplifiqué, digo, tú puedes hacerlo con simplificar, no pues como quieras. Ok, fine, questions? No?
Da mucho, pero no sé ni qué.
¿Y saben cuál es el problema? O sea, aquí, esta parte que estamos viendo ahorita, el problema es esto. Porque en este caso, por ejemplo, esto es lo que hizo el viernes.
Todo iba bien.
¿Sí? Y todavía tenemos otro ejemplo después en el que se vuelve cosas más largo. Pero ahorita no. Está divertida.
En el primer piso sí va a haber solo las
Técnicas.
técnicas, las
Sí,
fuerzas.
Después de que aplicaste la fórmula, que dice, allá abajo ve,
Ya toca.
no, lo integraste, no. O sea, eso lo multiplicaste, eso lo multiplicaste por medio, lo integraste.
Sí, perdón. Se paren. Ok. Fine. Can I continue? Okay. That's the first case. That's the first case. You have square root of a squared minus x squared. Second case, x squared minus a squared. Same situation, a triangle. Okay, now, this time, hypotenuse is what? According to my formula, x. And how can I decide the rest? Remember, I need to have x over a. That's mandatory, x over a. So, I need to choose in such a way that my other side is going to give us a function that when I find the derivative is positive. Explain again. Fíjense bien. Aquí es a fuerzas, ¿verdad? De acuerdo. Aquí por ejemplo, estoy poniendo x aquí y raíz aquí. ¿Lo puedo haber puesto al revés? También hubiera estado correcto. Raíz aquí arriba y el x abajo también hubiera sido correcto porque aplica Pitágoras y no hay ningún problema. Pero ahí les va. Si yo hubiera escogido x aquí abajo y la raíz aquí arriba, ¿qué función sería esta? Coseno, ¿verdad? Y como tengo que derivarla, porque es parte del proceso para poder sustituir, será negativo la respuesta de la derivada, será negativo seno. Yo no quiero negativos, me estorban en la integral. Entonces, por eso estoy tratando de buscar acomodar mis lados de tal manera que cuando ponga las funciones y luego las derive, me dé cosas positivas, funciones positivas. No les quiero dar una macheteada, ahí les va la reglita siempre así, no quiero que le piensen un poquito. ¿Sí? Entonces, en este caso, por ejemplo, piénsenle bien, x es esta. A puede ser esta o puede ser esta. Si la pongo aquí, yo te la voy a borrar, no la apunten. Si le pongo aquí la A, ¿qué función usaría? Hipotenusa entre opuesto.
No.
Cosecante. Yo te la voy a borrar, ok. Como decimos aquí, los dos despejamos y luego tenemos que derivar a fuerzas. ¿Cuál es la derivada de cosecante? Menos cosecante por cotangente. Yo no quiero negativos. Aparte que es co, y integrar cosecante, todo eso está más complicado. Entonces, no quiero la A ahí. Quiero la A mejor abajo. Si la pongo abajo, entonces cuando encuentre x sobre a, que es a fuerzas, ¿qué función usaría? X equal to a secant, and when I find the derivative eventually in the formula, the derivative of that dx is going to be a secant positive. Okay, so you need to arrange these values such as this, so at the end you have derivatives that are positive and no cofunctions. ¿Se acuerdan bien? No quiero cofunciones en esto. ¿Qué es cofunción? Cofunciones son coseno, cosecante o tangente. Lo vimos en mate 4. Les explico su maestro en mate 4 que una cofunción.
No.
Esta Insisto, no es por andar criticando a otras personas, no me gusta hacer eso, pero no me agrada que vengan con más de 6 o más de 5 semestre pasado sin saber cosas esenciales. Eso es lo que me frustra. Anyway, fine, so if this is x and this is a, this side is what? The square root. The whole square root, x squared minus a squared. Therefore, when I put square root of x squared minus a squared over the constant, what's the function that I need? Tangent. And the whole square root is a tangent. Do you understand that? You could memorize all of this if you want to, but the idea is to reason. It's not complicated at all. Good. That's the second case. Third case, third scenario. Can I read this? Okay. Same situation. Now I have a triangle again. Triangle is this one. Angle theta. Right angle. Okay. Which one is the hypotenuse? The whole square root. Yeah, perfect. The whole square root. X squared plus a squared. Why? Because of this. Which is going to be x, which is going to be a. Think a little ahead. Again, I want x over a. I need to have a function whose derivative is also positive. So I don't want cofunctions. So x here or x here? What do you think?
X.
Here? So this is one is x. Sorry, you said x here, right? X here and a here. So x over a is going to be tangent. X equal to a tangent. And the derivative, just to prove that we are correct, the dx is going to be a okay. So all of the x's are always functions, not cofunctions. Sine, secant, tangent. And the square root of x squared plus a squared over a is going to be equal to secant. Therefore, the square root x squared plus a squared is equal to a secant. And that's it. Very good. Questions so far? Dos, tres. Ah, está fácil. Eso es por trigonometría.
Ese es el problema
Digo fácil. Ok.
Es una clase de
Que no nos enseñaron bien lo de los. Pero esto, todo bien enseñárselos.
Profe, ¿cómo sabes si la hipotenusa es a squared o x squared?
Dejo de fórmulas. So check the placement.
Pero A es la hipotenusa siempre o
Depends on what you have. In this, yeah, there is a hypotenuse. In this, no. Depending on the cases. Yeah. Can I erase? Good.
Si está restando la si no, si está restando la X,
What?
si está sumando, va a estar como todo la raíz. Para la segunda, cuando X es lo próximo.
Sí,
¿2 semanas?
no, el próximo. Es el viernes. Ya hicimos más clase.
Ayer apenas para miércoles.
Positivo.
Ya se había dicho, las actividades van a ser para el miércoles. ¿Cuáles? Desde la que vimos la de Escopios, que nos has achicado, la del lunes, la del martes y la que hicieron ayer y la que vamos a hacer ahorita. ¿Cómo?
Vamos a hacer las actividades.
Son 5. Es que me falta otra de 50. Este es para el viernes.
El otro va a ser.
¿Tienen puente? Aprovechen.
Por eso, profe. Pero si no me hacer el enlace también es para aprovecharlo a descansar.
Está bien. Las actividades del año bonito.
Vamos a allá. Al cabo, como es maestro, por primera vez te hacen 50 descuentos. Es redondo y 500 pesos.
Bueno. Fine. Let's try this one, okay? This is the number 1 for the activity. Dx over x squared times the square root of x squared plus 9. Before I start, open your minds to everything, okay? Because this one is going to be a little, yeah, fun. Yeah, let's say fun. Okay? I just need to another group, just anyway, fine. This one is the case number 3, that one, that's why I left that one. It's x squared plus a squared. So in this case, for example, I build my own triangle. Which one is the hypotenuse? This is going to be x and this is going to be 3. 8, yes. So it's going to be x over 3 equal to tangent of theta. Therefore, x is equal to 3 tangent of theta. The dx also, dx is 3 secant square of theta d theta. And for the square root of x squared plus 9 over 3. So it's going to be secant. Therefore, 3 secant of theta. That's it. You can skip these two if you want to. I don't need to write everything. I'm just giving you that so you can understand what it means. But I want this, please. Substitution. Yeah. No quiero, por favor, que digan, me lo aprendí de memoria, pues yo no voy a ponerlo ya directamente acá. No, quiero la declaración de cambio. O sea, x es esto, la resta mínimo. Mínimo la declaración de cambio. El triángulo también es opcional. Pero esto lo quiero. La declaración de cambio entre variables. Si no, no es válido. ¿Ok?
Profe, ahí da igual si el 3 lo pones en el x y el x en el 3. en el lugar del triángulo.
No. Supongo que el 3, aquí la X es cotangente. No quiero cotangente.
Ah, ok.
Okay, so dx is 3 secant squared d theta over x squared is 9 tangent square of theta times the square root, which is 3 secant of theta. Did you understand that? I just changed everything. Everything. Por eso soy muy insistente en poner dx. Si ustedes se les olvida el dx, pues ¿cómo lo van a cambiar? El dx. Entonces, tiene su razón de ser. Can I simplify this? Yeah, so it will be 3 with 3, 1 of the secants with this secant. So now I have 1 over 9 secant over tangent square d theta. What do I do? How? The thing about this is that just like in math 4, you need to think ahead. Not a little, a lot. Because you need to know if what you do to change this is going to result in an integral that you can solve or not. For example, I can decide to change this tangent square into secant square minus 1, for example. It's empty. Well, I don't need that.
En términos de senos.
That's another option. Observe or think about that and see what happens. In this case, it's going to work, perhaps. 1 over 9 secant is what? Tangent is what? I apply reciprocals, tortilla roll, whatever. So 1 over 9, 1 over cosine square, cosine and sine square. So it's going to be cosine square over cosine and sine square d theta. Can I simplify that? Just one single cosine and sine square. Is that useful? Actually, it is. Then I go back to this.
Lo separas
Ah, sí.
sine with cosine and the sine, or 1 over sine.
No, simpler way. Yeah? I have a function there, sine, not square, just sine, inside the square, whose derivative is there, cosine, u du. I told you. Como les dije el lunes pasado, tienen que ver y derivar mentalmente. Entonces, aquí no me servía porque derivar de tangente secante cuadrado no me sirve. Aquí sí me sirve, porque seno está dentro del cuadrado, pero el puro seno su derivada es. O sea, sí está.
Profe, ¿y no podría ser cotangente por cosecante?
Cotangente por cosecante también. ¿También es otra opción?
Es lo que le dije separar. Eso puede ser cotangente.
Ok, pero a partir de aquí, pues también funciona. Y que ahora lo del UDU también. Digo, ya lo vi directamente, me va a dar lo mismo. Si tú ya ves que lo puedes hacer a cosecante cotangente y te va a dar algo directo, también se puede hacer. O sea, no hay una sola alternativa. Yo lo veo directamente aquí porque ya lo veo. Si no lo ven y pueden hacer algo más que les funcione, por supuesto. Si hago algo más y me sigo trabando, entonces no llego a nada. No trabajo al principio. Si tú lo viste ya, excelente. Okay? So in this case, for example, if I follow that, it's going to be 1 over 9 integral of 1 over u du. square. Yeah, sorry, square. 1 over u squared. 1 over 9 integral of u to the minus 2 du. Integral of that minus 1 over 9 u plus. Why? Because minus 2 plus 1 is minus 1, so goes to the denominator, over minus 1, so goes to minus here. If I follow you the u, if you change to cosine, cotangent and cosecant, then it's directly minus cosecant. If the answer is going to be the same. Minus 1 over 9 sine of u of theta plus c, which is this, minus 1 over 9 cosecant of theta plus c. What's cosecant? Minus 1 over 9. Cosecant is square root of x squared plus 9 over x plus c. That's the answer.
¿De dónde salió el cosecant?
1 over 7. Or you want to change 1 over sine and do it directly from here, I'll allow it, because sine is going to be x over the square root, but in the denominator. And then you apply the reciprocals to this. If you don't apply identity from here to here, fine by me, because the final answer is the one that counts. Even better, I called it. He said that instead of doing this, you change it to cosecant cotangent, and you're going to apply u to u to do it directly. There is one more step where you do this. So it's up to you. Yeah? Final answer? Yeah. Or you can put it. No. X. In terms of x. Good. Questions? Yeah, the good thing about this is that there are many ways to do, many procedures to follow. So we can use the u or maybe not to get the final answer. That final answer. Whatever. Tú puedes hacer más allá. Questions? No? ¿Tú dices? At least it's one. Dejen que veamos también después con valores. Y les voy a demostrar con esto cómo encontrar la forma del área del círculo. Anyway, les voy a dar sus quizzes ya con la calificación mejorada.